Hello everyone, and welcome to Lesson 7 of DeTech Theory's Introduction to Computer Science course. My name is Vasundhara Bakchi, and this is loops. Okay, so what exactly are loops? Loops are basically structures in code that are used to execute a set of instructions multiple times. The instructions in a loop are repeated until a certain condition is satisfied. Loops are also called iterations. So why do we need loops? Our computers have limited memory, so it's essential that we make best use of it. Loops help us shorten our code, thereby making it less tedious to go through, as well as saving a ton of space. Right, so there are 4 kinds of loops: for loops, for each loops, while loops, and do while loops. We're going to learn more about them in the coming slides. We start off with for loops. So now there are 4 parts of a for loop as well. The first one being initialization. Initialization is the initial condition that is executed once the loop starts. Here we can initialize the variable, or we can use an already initialized variable. Condition is the second part of the for loop, which is to be executed each time to test the condition of the loop. It continues execution until the condition is false. It must return a Boolean value, either true or false. It is an optional condition. Statement of the loop is what is executed when the loop runs, that is the body of the loop. Then we have the increment or decrement operator, which basically, as the name suggests, increases or decreases the value of the variable, which controls the loop. We use a for loop when we know the number of iterations we want to perform. Now we go on to the syntax, as you can see here. For, then we have the initialization semicolon, condition semicolon, the increment and decrement. Inside we have the body of the loop, or the statements that are to be executed when the loop runs. So let's understand this better with an example. Over here the code is int sum equals to 0, and then for loop int I equals 1, I less than equal 5, I plus plus, and then sum plus equals to 1. So what exactly is this doing? So first of all, it initializes an integer variable called sum, which is 0, and then we start the loop. So as we know, it is initializing the variable I to 1 before the loop starts. So the condition of this loop, as we can see over here, is that the loop will continue as long as I is less than or equal to 5. And the second one is after the one iteration of the loop is completed, it increases the value of I by 1. All right, so let's run through this together. So first, when we start the loop, I equals 1, right? I is less than or equal to 5, so we go inside. So sum plus equals 1, this means that if you increase the value of sum by 1, so sum is currently 0, so if you add 1, sum is 1. Then I plus plus, I is now 2. Is 2 less than or equal to 5? Yes, so we go back in. So we go sum plus equals to I, sum is 1, so 1 plus 2 equals 3. And then we keep continuing this until we reach I equals 5. And so what do you think the sum will be once the code segment is entirely executed? 15. All right, then we go on to while loops. A while loop is a kind of loop in Java that runs so long as a particular test condition is true. When this condition is no longer true, the loop automatically stops. While loops are usually used when the intended number of iterations is not known. So let's go through the syntax. While a certain condition is true, this body code is executed. We'll go on to the next one. All right, an example of a while loop. Again, so int sum equals 0, we set our counter to 1. So the condition is that while counter is less than or equal to 5, we're going to add the value of counter to sum and then increase the value of counter by 1. What it does here is the first counter starts off with 1. Is 1 less than or equal to 5? Yes, it is. So you increase sum by the value of counter. So you add 1 to sum. Now sum is equal to 1. And you increase counter by 1. So now counter is equal to 2. Is 2 less than or equal to 5? Yes, it is. The sum equals sum plus counter. So basically, 1 plus 2, 3. Then we increase the value of counter by 1. Now counter is 2. So you go back up and you keep continuing this until counter is equal to 5. All right, so let's look here and see what the sum will be once the code segment is entirely executed. As you can see, the same as last time, we keep adding the value of counter by increasing it by 1. 1 plus 2 plus 3 plus 4 plus 5, which is equal to 15. So over here, we have to note that we increase the value of counter by 1, or we end up with an infinite loop. So to understand this, so if counter starts off with 1 and we don't have this sentence, it's going to keep, the value of counter is not going to increase. The value of counter is always going to be less than or equal to 5, which means this is always going to keep happening. It's going to go into an infinite loop. And we don't want that. So we have to remember to increase the value of counter by 1. All right, now we go on to the do-while loop. The do-while loop is a variant of the while loop, wherein this loop will run at least one time, then check if the condition is true. If the condition is true, the loop will run again. Like the while loop, it will only run if the condition is true, but the difference is that it will check for the condition after it has completed one iteration. All right, to understand this, first we go to do, which means it's going to do the iteration one time, and after the first iteration is completed, it's going to check if the condition is true. If the condition is true, it's going to go back and do it until the condition is false. All right. Okay, so now we have the for each loop. A for each loop is also called an enhanced for loop. It is something that we will understand later in a lesson about arrays and array lists, but here's a bit of basic structure for the for each loop. Every for each loop is a variable that has the same data type as that of the element of the iterable item, an example of which is an array or an array list. But we will learn more about this at a separate lesson, so don't worry if you're a little confused about this right now. So instead of acting as a counter variable like in the for loop, this variable itself refers to an element of the iterable object, starting from the element 0. Okay, so now we have the differences between while loop and for loop. So we know while loops are used when the number of iterations is not known, and the for loop is used when the exact number of iterations is known. So while loop, you just know a condition, you don't know how many times you have to run the loop. So then you know it's preferable to use a while loop. Second difference is that there is no built-in control variable for while loop. So do you remember the counter variable? So if we hadn't increased the counter variable by 1 each time we ran the loop, we would have got an infinite loop. And that's not something that the for loop does, because the for loop itself has a counter variable embedded in it. So each time the for loop runs, the counter variable does its job, and then it satisfies the condition and it exits. So you know it's not going to go into an infinite loop if your initialization, your condition are declared properly. Okay, so what's the difference between the while loop and a do-while loop? A while loop is an entry control loop. The test condition is checked before the iteration happens for the first time, whereas the do-while loop is an exit control loop. The test condition is checked for the first time after one iteration is completed. So we know that in a do-while loop, the loop is going to run at least once, whereas in the while loop, there is no certainty. Only if the condition is satisfied will the while loop run, whereas in the do-while loop, you will always run it once, and only then will the condition be checked for the first time. Coming to the second difference, it's pretty much the same. It's entirely possible that the condition for the while loop is going to be false when checked for the first time, so the loop doesn't even run. But in the do-while loop, the loop will run a minimum of one time. So even if the condition is false, you're going to have the loop run once. Hi everyone, welcome to Lesson 5 of DeTech Theory's Introduction to Computer Science course. My name is Asundara Bakchi, and today we're going to be learning about strings. So what exactly are strings? We've learned about this before in a previous lesson, but just to recap, strings are essentially sequences of characters that are mostly used to store sentences, but can also store separate letters, numbers, etc. We have to note that numbers stored in a string variable cannot be used for arithmetic functions. These are stored in an int variable. Now we go on to string methods. There are many string methods in Java. Over here, I've only listed a few, which are very important. So let's look at them. So if we start off with a precondition, string x equals to hey, and string y equals to hello, and then we look at the string methods in that context. For example, the first one, car at. Car at returns the character at a specific index or position. For example, x.car2 would return the character y, which means that if you look at x and if you look at the first index, index 0 is h, index 1 is e, and index 2 is y. So it returns what is at index 2, that is y, as a character. Then we look at compared to or compared to ignore case. So compared to does something called a lexicographic comparison. That is, it compares and returns the numeric difference between the first difference between the two strings. If they are the same, it returns 0. This number can be negative based on what two values you're comparing. For example, let's look at x compared to y. This returns 13. And how do we know that? Because if you look at the two strings, the first difference is when y and L occurs. So since it's x compared to y, what we're going to do is take y minus L. And how do we know what y minus L is? So we can do this by taking their ASCII values, or simply the fact that L is the 12th letter of the alphabet and y is the 25th letter of the alphabet. So if you go y minus L, that is 25 minus 12, we get 13. And now we have something called equals or equals ignore case. What this simply does is that it checks if the two strings are exactly the same, and then it just returns a true or false statement. For example, x dot equals y would return false because hey and hello are two different strings. Okay, so now we have a few more string methods. Again, we have the same preconditions, except we have a newer precondition, which is called test, which is the word test with a few white spaces before and after. So let's look at the index of method. The index of method returns the position of the first found occurrence with specified characters in a string. For example, y.index of L would return 2, because in the string y, the letter L appears for the first time at index 2. Now, last index of works very similarly to index of, but it just returns the last occurrence instead of the first occurrence of something. For example, let's go y.last index of L. Now this will return 3 because the first occurrence of L is at index 2, but the last occurrence of L in this particular string, it is index 3. So that's what we're going to return. Now we have the two lowercase or the two uppercase methods. Now what this does is simply just converts the string to a lowercase or uppercase. For example, if you take x.lowercase, this would return hey in all lowercase letters. And if you go y.uppercase, it will return hello in all uppercase letters like this here. Now we're going to a different method called trim. What trim does is just simply removes the white spaces from the two ends of a string, so you just have the string in itself. For example, k.trim would just return the word tests without any spaces before or after. Now we go on to substrings. Substrings are very important in our understanding of strings. It is essentially extracting a small part of a longer string as a separate, shorter string. If you look at the syntax, we see that there are two ways of taking substrings. One is just to include the index from which we start extracting, and the other is to include both the start and ending index. We must note here that the end index applied is not included in the substring. That is, it will only include it till the previous index. To make things a little clearer, let's look at an example. So over here, string x equals apple, and x.substring 2. So what we do is we start at the index 2. So let's go 0, 1, 2. So we start here and we go all the way to the end. So the new substring will now just contain P, L, and E. Then we go on to x.substring 0, 3. And remember we said about the last ending index not being included. So what will only be included in this particular substring is the indexes 0, 1, and 2. So let's go here, index 0, 1, and 2. So the substring will contain APP. Now we go on to string length. Being able to find the length of the string is very important, and this is done through the dot length method. What this does is it returns the length of a particular string, including any white spaces that may be included. What we have to note, though, is that unlike indexes, the length starts at 1 instead of 0. Now let's take a look at an example to make things a little clearer. The string x equals apple, and then string y equals my name's DeTech. So if we go x.length, all it does is count the number of letters in the word apple, which is 1, 2, 3, 4, 5, and returns 5. And over here, y.length, it counts the entire length of the sentence here. That is 1, 2, 3, including the white space, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. And that's going to be the length of y. Now we go on to some practice problems. So if you look at the preconditions, string test1 equals hello world, string test2 equals tomato, string hi equals yes with a capital Y, and then string hi3 equals yes in all lowercase, and then string hi4 equals hi2 dot lowercase. All right, so let's take a look at these. Test1 dot substring 0, 2 plus test2 dot substring 4. Now let's break this step by step. Test1 dot substring 0, 2, which means we start at 0 and we end at 2. So 0 and 1, because we don't include the last index, and we get the words HE from here. All right, so we keep it, and then we go test2 dot substring 4. What this means is we have to start at index 4. Let's go to test2. Let's go to index 4. 0, 1, 2, 3, 4. Right? So now we have to go from 4 all the way to the end. So these are the letters T and O. So HE plus T and O would give us heto. There we are. Now we go on to the next one. Test1 dot length. So all we have to do is count the length of the string here. 1, 2, 3, 4, 5. We count the white space, so 6, 7, 8, 9, 10, 11. There we go. Then we go hi3 dot equals hi4. So what this does is just compare this string and this string. So hi2 dot 2 lowercase would give us yes in all lowercase again. So if we compare yes in lowercase to yes in lowercase, it's going to be the same string. So this will equal true. Now we go on to the last one. Hi3 dot compared to hi4. So as we said previously, those are the same strings, right? So, but compared to is not going to return a Boolean value. Instead, it's going to return 0 for the same string. There we go.
Thank you for joining us on today's lesson. I hope you guys learned something and enjoyed it. If you have any questions, comments, or any feedback at all, please contact us at detechtheoryco@gmail.com and visit our website, detechtheory.com. If you have Instagram and are willing to use it, please visit our page at DeTech Theory. We share lots of reels and cool coding tips and tricks as well there. That's it for today, folks. Please like and subscribe. And I hope you come back and look at our other videos on this series as well as more. Have a nice day and happy coding.